In this video, we'll be talking about compound interest. To compound interest is to roll the interest into the principal. Now, to understand this whole concept, there's a lot of language associated with it. First of all, the principal is the amount that you, originally the principal, like if it's a loan, it's the amount you take out in the loan. But every little bit, they compound the interest and roll the interest value into what you owe, and that becomes a part of the principal. So the principal is what you owe. Kind of the same thing if it's an investment, you have your initial investment, but then you gain interest on that, and then every once in a while they'll calculate that interest and roll it into how much you actually have invested and then reinvest that higher amount. So that's the idea of principal. And then there's some other stuff. So we got some formulas down here. There's two different types of interest we're going to be talking about. We're going to talk about interest that is compounded periodically and interest that is compounded continuously. And there's these formulas for calculating. There's a lot of letters in the formulas. So I've outlined up here what all those letters mean. A is the balance. T is the number of years you're going to invest something, or the number of years you're going to carry the loan. R is the rate of interest. And N is the number of times it's compounded in a year. For N, that only matters for this formula. If you notice down here, there's no N's in the compounding continuously because it's not a number, it's just continuously compounded, so we're not counting it. But for the periodically compounded, N gives us how many times it is periodically compounded. And so that leads us to these words over here. Annually means it's compounded once per year, semi-annually is twice per year, quarterly is 4 times per year, and monthly means it's going to be compounded 12 times per year. The more times something is compounded, the better it is if it's an investment. The worse it is if it's a loan, basically, because every time it's compounded, that amount of interest value is added into the principal. So that becomes your money, essentially, if it's an investment, or it becomes what you owe if it's a loan. So we're going to move on to an example now. So go ahead and take the time, pause the video, take the time you need to write all this out, and then we'll switch over and do a couple of examples, one for compounded periodically and one for compounded continuously. Alright, here is a problem for us to work on. You deposit $1,500 in a savings account that has an interest rate of 4%. Find how much money will be in the account after 5 years, assuming it is compounded annually. Now, with this problem, we're also assuming that you're not going to make any withdrawals. So this is assuming you put the money out there and you just leave it to grow. So this is going to use our compounded periodic formula because it tells us it's compounded annually. If you're going to use the compounded continuously problem, it will say it's compounded continuously. All the other options are for compounded periodically. So our compounded periodically formula is A equals P times the quantity 1 plus R over N to the power NT. I encourage you to write this out in this raw form every time you use it to help you memorize it. Now, A is what we're looking for. A is the amount you have after a certain period of time. P is the principal we started with. So that's going to be $1,500 in this case. And then 1 plus our rate is 4%, but when we plug that into the formula, we want to convert it to a decimal. So you're dividing that 4 by 100, or shifting the decimal place 2 digits. And then N is the number of times it's compounded annually. In this case, we're compounding once annually, so N is going to be a 1. If we are compounding quarterly, N would be a 4, etc. So then in the power we have the N again, so in this case it's 1, times T is the number of years we're looking at. That's the 5, so that's going to be 5. So in the end, your power ends up how many total times it's compounded for the duration of what you're looking at. Alright, so then you just grind this out. Some calculators can let you just enter all that in and hit equals. I would just encourage you to be careful with that if you don't have a calculator that allows you to see what you've entered in. So you can make some adjustments here or grind this down a little bit without your calculator. Something divided by 1 is just itself. 1 times 5 is 5. It just makes it a little easier to plug into your calculator. 1500 times, now 1 plus 0.04 is just going to be 1.04 into the 5th power. And then at that point, I would switch over to using my calculator. When I do that, I'm going to get that this whole mess is approximately 1501.216653. And of course, that's where my calculator stops, but the number goes on. And this is where it's important to remember we're talking about money, and so what makes sense there is to round to 2 decimal places for cents, unless we have directions that say otherwise. So after 5 years, you would have $1,501.22. So you would have gained $1.22. This is not a good investment strategy. There are better ways to invest. All right, so that is the compounded periodic problem worked out. Now we're going to do one for compounded continuously. All right, here's a nice compounded continuously example. You invest $1,500 for 6 years at 3.5% interest compounded continuously. How much will you have at the end of 6 years? So again, this is anytime you have compounded continuously, it'll use that word, and that'll tell you to use the continuous formula. If it doesn't use the word compounded continuously, then you're using the periodic formula. So the compounded continuously formula is A equals P times e to the RT. I call this the PERT formula, but it's important to remember that the RT is in the exponent. Now, if you look at all of the letters I defined earlier, I didn't really talk about this E. E here is not a variable. E is a number. It's kind of like a number like we use pi, where it's an irrational number, so we just use a symbol to represent it. So when we plug our values in, E will stay E. So plugging our values in, we get our principal is 1,500 times E. Our rate is 3.5%, but again, we need to change that to its decimal expression. So we're going to divide it by 100. It's going to be 0.035. And then we're going to times that by the number of years we're going to invest. So that's going to be times 6. Notice there's no n in this formula because n is the number of times it compounds per year, and this is just compounding continuously, not a number of times per year. So what I like to do is first figure out what my exponent is. So I punch that into my calculator, and it tells me that it's 0.21. And then after that, what you want to do is, like I said, this E here is like pi, and just like you have a pi button on your calculator, you'll have an E button on your calculator. You'll just have to find that. So when I punch all that out on my calculator, what I get is that this is approximately equal to 1,850.51709. And again, since we're dealing with money, unless we're indicated otherwise, we're just going to round it off to the nearest cent. So after 6 years, we'll have $1,850.52, which means we gained a little over $350 because we started with the 1,500. So we gained a little over $350. Alright, so that's the idea. If you're having trouble finding your E button, you can let me know, but that's just a number on your calculator that you press. Let's go ahead and give some of these a try and see how you fare.